Good morning, everyone. This is, I think, Circular Dynamics lecture number 6. I think this is wrongly written. 5 was the last one. This is Circular Dynamics lecture number 6. And what are we going to do in today's class? To understand what we are going to do in today's class, we must go back and see what we had done in the previous class. What we had done in the previous class? Anyone has any idea what we had done in the previous class? I told you to go through that class once again so that you become well acquainted with the various steps that are involved in solving problems in circular motion. Have you all gone through that? The previous lecture, everyone is comfortable that we know what was done in the previous
Sir,
lecture. Yes or no? I
steps
can't
for
see,
solving problems, sir.
right?
Sir,
Yes.
do you hear me?
Yes, I can hear you better.
Steps for solving problems, sir.
Okay, we were doing steps for solving problems, and I would request host to make the other ID uh, co-host as well, because I'm not able to do anything from that ID. So I'll request them to make them co-host as well. Anyways, we were dealing with steps that are required to solve problem in center of mass. And if I go back to that class, as we always go, so what were the steps that were involved? The first step was obviously to draw the free body diagram, which has all the forces acting on all the bodies. Then we resolve the forces along three axes, and we had seen what are those three axes. The first axis is along tangent, the second axis is along normal or towards the center, and if required, the third axis would be perpendicular to the plane containing the circular motion. That was the three steps. Then what we had to do after these three steps? After these three steps, we had to make equations along these three directions. The net tangential force Ft would be equal to m into at. The net centripetal force towards the center Fc would be equal to mass into centripetal acceleration Vt square by r, m into Vt square by r. There is no motion in the perpendicular direction. Remember, if you had something placed on a plane, nothing moves like this. Similarly, when something is moving in a circular path is motion in a plane. It is motion in two dimension. If something is moving like this, it cannot move like this. Along the plane, it will move. Perpendicular to the plane, it will not move. So, in the perpendicular direction, all the forces must balance out each other. Do we all remember those steps? Can I have some raised hand that we remember them? Okay, I feel everyone remembers those steps, and that is good. I hope you have gone through the lecture once again and become comfortable with those steps that we had discussed. I don't know what is wrong with this. It is so big. Anyways, those were the steps that we discussed. Now, what we got to do in today's class is try and understand how are we going to utilize those steps in solving problems, and how are we going to do that? We are going to take some examples of some circular motion, and we are going to apply those steps to understand how it works. I hope you have the notes with you. So I would request now that we'll be opening those notes. I hope you have it. You have the notes with them. I'll just open them for you. What's happening? I'll just open those notes and here are they. Everything has gone wrong with my system today. So we are going to apply those principles on a variety of problems. And the first problem, the first set of problems that we are going to do are known as problems of circular motion on a horizontal plane. Now, what do you mean by a horizontal plane? Motion in horizontal plane. Now, remember, whatever questions we are going to do on circular motion in this particular chapter, the entire question is based that the motion is taking place on Earth. We are not, you probably not be dealing with motion where planets are moving around sun or satellites are moving around Earth, because that is in gravitation. Moon moving around Earth is circular motion. Planet moving around sun is not circular, it is elliptical. And I hope that it is being covered in gravitation. So we are not going to deal with motion of stars and suns and planets and satellites. We are going to deal with motion in everyday life. When I say everyday life, what I mean is motion on Earth. Now, when you talk about motion on Earth, there are, you can divide the entire motion which are going to come along two planes. One is the vertical plane, and I hope all of you understand what is a vertical plane. This, my hand, right now, let us not use my hand. Let us use this book. Let us use this book. If a motion is taking place like this, see, this is a vertical plane. This gentleman is a vertical plane. Just give me a moment. This gentleman is a vertical plane. Okay, I'm back. I just lost power. Okay, if the motion is taking place along this plane, if I want to make you understand in terms of gravity, if the motion was taking place like this, that was motion under gravity. Now a plane which is like this, motion can take place like this, the motion can take place like this. But we are talking about circular motion here. Now when it's circular motion, the motion is going to take place like this on this plane. I hope everyone understands this. This motion is known as motion on horizontal plane. Motion on vertical plane. This is a vertical plane. Motion happening on this plane is known as motion in vertical plane. This plane is vertical. Gravity is acting downwards. Gravity is always acting downwards. Gravity never acts upwards. Gravity never acts in the horizontal direction. For us, gravity of Earth always acts in the downward direction. This is the vertical plane. Motion that happens in this plane is known as motion in a vertical plane. We'll be having a lot of discussion on this motion. But first, let us discuss about motion in a different plane. This is a vertical plane. Now, if this is a vertical plane and the topic is motion in horizontal plane, how does the horizontal plane look like? This is the vertical plane. We're talking about motion on Earth. This is vertical plane. Then what is the horizontal plane? How does the horizontal plane look like? This is vertical. Can anyone tell me how will a vertical plane look like? No idea, anyone? I can't see you guys. Why I'm not being made the co-host? Who is there in the class? Can anyone make the other ID co-host? Just make the other ID co-host better because I just can't shift. Okay, that is great. Now I can probably do some things with this one. Just really everything is gone. Why I can't make the change over here? What's wrong? I can only see my bloody photo. Why can't I see yours? What's wrong with this bloody system? I can't see you guys. What's wrong? What's wrong with this bloody system? I can't pin this. Stupid. Where it is gone? I want to see the other thing here. How do I see it? Okay, leave it. Done something wrong. Okay. This is the vertical plane. How does the horizontal plane look like? Anyone?
Perpendicular to the vertical plane, sir.
Now, perpendicular to vertical plane, there could be this plane or there could be this plane. Which one? This one or this one? This is the vertical plane. There are three planes that I can draw here. Vertical here. One is this one. And the third one is this one. Which plane are you talking about?
Second
Vertical.
one, sir.
Which one?
No, sir.
This one?
Yes, sir.
Yes. This is the horizontal plane. So any motion which is taking place on this plane, like this, ting 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 ting. This is motion in a horizontal plane, and that is what we are going to talk on the first stage, motion in a horizontal plane. Now, since we have understood what is motion in horizontal plane, can anyone give me examples of motion in a horizontal plane? Any example of motion taking place in a horizontal plane? And there are millions of examples, infinite number of examples. Can anyone cite any example of circular motion in a horizontal plane? Any example of circular motion in a horizontal plane?
Moving of car, sir.
Moving of a car. We're talking about circular motion here. So a car turning, a car turning on a circular track. A car turning on a circular track is motion, circular motion in a horizontal circle. Yes, anything that is moving on earth is basically moving on a horizontal plane or horizontal plane of earth. If it is moving in a circular path, and I told you any path is circular path, a part of it is a part of a circle always, and we'll understand what is this radius of curvature and center of curvature. So a car moving on road, turning on a road is a case of motion in a horizontal plane. Now another example is right now on your screens. Can anyone tell me what is this example looking like? What does this example say? This is example number 15, I guess. Example number 15. What does this example say? Can anyone understand what type of motion is happening here? And can you anyone illustrate what is happening? Yes, bacha, tell me. What is happening here? Okay. Let us say this is the table, horizontal plane. And what I have done on this horizontal plane, I have some hinge, some fixed point, some nail, and I have attached a thread on this nail, and then I have attached one small stone or block, and then I am moving this block on this horizontal plane. So this block is attached by a string. I gave you the example of that langar that I used to play when I was a kid. That langar I used to rotate like this, ding, 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 ding. So it was moving in a vertical plane. Right now it is not moving on a vertical plane. I have kept it on a table, and then I am moving it on the table. So this becomes example of a circular motion in a horizontal plane. Do we understand this, everyone? That this is an example of circular motion in a horizontal plane.
Yes, sir.
And the question right now is very simple. I have a block of mass 2 kg. Instead of taking it as block of mass 2 kg, let us make it general. Let us make it a block of mass m. A block of mass m is tied with a string of length L. Instead of 2 meter, let us take it as L, so that we get the answer in the most general form. A block of mass n is tied to a string of length L, and the other end of the string is fixed. Remember, it is fixed. One point is fixed. Then that is how it is moving in a circular path. The block is moved on a smooth horizontal table, so there is no friction. Friction can also come, and friction will come. Don't worry. And it will not make life difficult. It will make life easy. So it is moved on a smooth horizontal table with a constant speed. Instead of calling it as phi, we will let us call it as V or Vt, whatever you want. So I have a block of mass m attached to a string of length L, moving on a smooth horizontal table with a constant speed. Remember, they have told constant speed and not constant velocity because it is continuously changing direction. We have to find the tension in the string. Can you all solve it? If you can do it on your own in the very first day, on the very first question, well, my job is done and you have understood the entire concept. If you can't do it, don't worry. I will be solving it. I will be giving you a template, and then you should be able to solve it. But if you can apply that template on your own and solve the question on your own, there is nothing like it. Nothing, 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 nothing like it. So I'll give you your time of showing your skills, a minute, and I'll be back after a minute. I'll give you a minute to solve it. So anyone with any answer? Anyone has got any answer that you would like to share? Or
45, sir. Tension.
instead of giving me the numerical value, can you tell me the answer in terms of M, V, and L? Instead of giving me the numerical value, can you give me the answer in terms of M, V, and L? Mass is M, length is L, and the speed is V. Can you give me the answer in terms of N, V, and L? M, V, and L? Anyone?
T minus mg is equal to m into vt square by L.
T minus mg. Okay. Okay. T minus mg. So I'll just write what you're saying. T minus mg is equal to mvt square by L. So my T becomes mvt square by L plus mg. Is this what you are saying, bacha?
Yes, sir.
Okay. Anyone else with a different view of this question? Anyone with or everyone in the class is agreeing that this would be the answer that we would be getting? Everyone got the same answer? Can I have some raise hand that everyone got the same answer? I don't see anyone. So maybe someone else has got a different answer. Yes, but I see your hand. Someone else got a different answer, or none of you got any answer? Okay, I have some message on the chat. Let me have a look. Sir, 25 Newton. Harshita got an answer. 25 Newton, and she is telling me that it is mv square by L. And Harshita, I must tell you that your answer is correct. It is mv square by L, and it is not mv square by L plus mg as what is being just now discussed in the class. So this is not correct. I will have to take it out. The answer is simply tension will be equal to mv square by L. Now comes the part where we try to understand how this answer has come. So the answer is mv square by L. Answer is not important. You can always get an answer even without understanding the question. The important part here is to understand what is happening here, to understand the motion. Now, when I draw the motion like this, I am not very convinced. This gives me an idea that the motion is somehow taking place on this vertical plane, and when I see the circular motion like this, I really get very confused. This motion is not happening on this plane. We have to understand that this motion is happening on this plane. And now the problem with me, the problem here is that I cannot draw this plane on this board, because it becomes very difficult to draw this plane on this board unless and until we understand that the board of the plane of the book that you are writing, or the pad that I am using, is horizontal. It becomes sometimes difficult to understand this. So what I'm going to do is draw it and try to make some sense out of it, that it is now making sense. So what I'm going to do is draw it and see how I'm going to draw it. Remember, we have to make it very clear in our heads, also in our diagram, that this is a horizontal plane. So how I am going to draw it? See, this is my table. This is my table. So I draw my table. Now this motion, this is the table is kept on the vertical plane. So this is on a vertical plane, but the motion is not happening in this plane. The motion is happening like this. Now how do I show this motion? To show this motion, I have to understand that the table is going inside, and when table is going inside, and the motion will take place like this. So how I'm going to draw it? I'm just keeping the table here, and I am going to draw the motion like this. Tung 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 tung. And I'm going to draw the motion like this. Remember, this motion is taking place right now in and out of the board. So I imagine that the body is fixed on the board, and it is going inside, and then it is coming outside, then it is going inside, then it is coming outside, then it is going inside, then it is coming outside. If I look from this end, what do I see? I would see that this is hinged over here, and there is a string attached here, and this block of mass M is kept here. Now this block of mass M will go inside, dung 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 dung, then it will go inside, then it will come here on this end, then it will come outside, dung 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 dung, then it will again go inside. Do we understand how this motion is happening? Into the plane, turning inside the plane, then coming out, then coming out, then going inside, then coming out. So this is how this motion is happening. Now why it is easier to understand it in this way? Because once I understand it in this way, I understand that the weight of this block is downwards, mg, like this, and the normal reaction is coming from the table, and it is like this, and the tension here is towards the center. This is the center O. The tension is like this, and this is how the motion is happening. Again, let us try to make sense. This is the horizontal table. Tongue tongue tongue. Let me take a smaller pencil. This is okay. This is my string. The string is kept like this. See, the string is like this. It is hinged over here. Here there is mass. And now I'm moving it like this. Tung 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 tung. So you see, the weight of this block is acting downwards. Tung. It has got nothing to do with the tension. Tension is like this. Weight is downwards. Tension is like this. And that is what I have drawn in the diagram in red. Do we all understand this? How does the motion look like? Can I have some raised hand that we understand this? Great. Now I have drawn all the forces acting on this block. That was my first step. Draw all the forces acting on the block. There are three forces that I see here. One is tension T. The tension in the string. Number two is my normal reaction N coming from the surface of the table. Number three is my gravity always acting downwards. Now remember, there is no friction. There is no friction. So if there is no friction, there is no force along the table. There is no friction on the table. So there is no force along the table. The only force is the tension force. Other force is normal reaction upwards. The other force is weight downwards. Three forces. Now let us resolve these forces in three directions. Three directions. Remember, we have to resolve forces. Now, can anyone tell me what are those three directions looking like on this question? In this question, how are the three directions? Three directions looking like. Three directions, remember. Three directions. Can anyone tell me how are these three directions looking like? How are these three directions looking like? The first direction is tangential. Now remember, this motion is happening like this. If I have to draw the tangential direction at this point, the tangential direction would be going like this into the plane of the paper. Yes or no? It is going inside the plane of the paper. That is my tangential direction. Instead of drawing it like this, I have probably drawn it in the wrong direction. So what I'll do, I will draw it like this. Oops, I've made, I can't correct it. So I'll have to take the pen again and use it again, and then draw the mass M again. And then I'm going to draw the tangential direction. The tangential direction is going inside into the plane of the paper. This dot dot T is the tangential direction which is going inside the plane of the paper. The second direction is, this is the tangential direction. This is going inside the plane. Now to draw inside the plane, instead of drawing it as it is dot dot dot, I can draw it as cross. So when I draw cross, this cross means something is going in. Cross means something is going in. So from this side, this block is going in, and from this side, the block is coming out. Coming out means it is seen in the form of a dot. Something coming towards you, an arrow coming towards you, you will see the dot of the arrow. If the arrow is going away from you, you will see the cross of the arrow going. Have you seen a train? When it's coming towards you, there is a big light of the engine of the train that you can see. Okay, the train is coming. Big light is dot. When you see the last bogie of the train, you see a cross written on that bogie. Cross. When you see that the bogie is going away, you will see the cross. Cross means going away. Dot means coming towards. Do we understand this? Dot means coming towards. Cross means going away. So the tangential direction looks like this. Now when I write equation along this direction becomes my centripetal direction, which is towards the center. Yes or no? The second direction is centripetal, which is towards the center. One is tangential, which is going into the board. The other one is centripetal. The third direction is perpendicular to the plane of the board. Now remember, this plane is, the motion is happening on a horizontal plane. So which is the direction which is perpendicular? The perpendicular direction is the direction where this normal reaction is going. So these are the three directions in which you have to make the equations. Tangential into the board, centripetal towards the center, and normal, which is up down, up down, up down, up down. Now, what are the forces acting on this tangential direction? Remember, there is no friction. There is no friction on this table. There is no friction. So even if the block is moving like this, there is no friction. So there is no tangential force. So my F tangential becomes 0 because there is no tangential force. Do we understand this? Can I have some raise hand if we understand this?
Yes, sir.
Well done. If there was a frictional force here, we will do that question as well. Just now we will do it. We will then discuss what will happen in the tangential direction. Right now, there is no tangential force, so Ft becomes 0. That is my first equation along the tangential direction. I have done it. Done and dusted. Let us now move on to the second direction, which is my centripetal direction towards the center. Now tell me what force is acting towards the center, whether the block is here on this side, right hand side, or when the block comes here towards the left hand side. Tension is always acting towards the center. What is the centripetal force? Whether I look it from here or I look it from there, what is the centripetal force? How much is the centripetal force? The net centripetal force is equal to the tension T. Yes or no? There's only one force acting in the direction of the center, which is the tension T. Yes or no? Do we understand this? There's only one force acting in the centripetal direction, and that is your tension T in the string. Do we understand this, everyone, bacha?
Yes, sir.
So this net force tension T will be equal to your M into AC, and that will become M into V square by L. Do we all understand this? This is my equation in the centripetal direction, which is the second direction. Instead of writing it as V square, you can also write it as VT square. Doesn't matter, it means the same thing. One more equation remains in the perpendicular direction. Can anyone tell me what is that equation number 3 in the perpendicular direction? Remember, it is not asked in the question. Question doesn't ask you that, but I am asking you that. What is the third equation? Can anyone tell me what is the third equation? What is the third equation? Anyone in the online class? Anyone in the offline class? Can you tell me what is the third equation? No one can tell me what is the third equation?
F equals to 0.
The third equation is, in the upward direction we have N, in the downward direction we have mg. The forces should balance in the perpendicular direction. That is what I said. The forces will balance in the perpendicular direction. Here the upward force is N, the downward force is mg, and N will be equal to mg. That is how they will balance each other, and that becomes my net force in the perpendicular direction is equal to 0. Upward force will be equal to the downward force. Equation number 1 is force in the tangential direction. There is no force. So Ft is 0, no equations there. Equation number 2 is equation in the centripetal or radial direction. Net force towards the center is T. That T must be equal to mv square by L. That is equation number 2. Equation number 3 is in the perpendicular direction. There is no force in the perpendicular direction. The forces should balance in the perpendicular direction. Upward force must be equal to the downward force. Upward is N, downward is mg, and that is how you can get the values of everything. The value of tension is mv square by L, and the value of normal reaction is mg. Do we understand this, everyone, in the online class and the offline class? Can I have some reason that you understand this? How we have applied this principle, 3 axis, tangential, centripetal, and in the perpendicular direction. In the perpendicular direction, always the forces will balance. Upward will be equal to downward. If it is in upward downward direction, they will always balance out each other. I'll give you a minute to note this down. If you have any problems, any doubts, you can raise your hands and ask your doubts now. I hope everyone has noted this down. Yes or no?
Yes, sir.
Okay. Now, what I'm going to do here is change the question slightly. And how would I put the question now? I would put the question like this. A block of mass M, please note down the question. A block of mass M is moving in a circular path on a table moving on in a circular path on a table attached to a string of length L. The coefficient of friction is mu. Find number 1, tension T in the thread. Number 2, the value of normal reaction. Number 3, the value of the frictional force F. Need to draw a diagram and solve the question right now. I'll give you a minute to do this. I hope everyone has done the question. Okay, how are you going to solve this? Anyone has any idea? Online class, offline class? So first of all, what we got to do is draw a free body diagram showing all forces. Again, I am going to draw the free body diagram. This is motion in a horizontal circle. I will draw the free body diagram like this. This is the center. This is the block of mass M. And this is my horizontal table. So this is my horizontal table. Do we all understand this? This is my horizontal table. Now I will draw the forces which is acting on this. So one is the tension T, which will be like this towards the center. If there is no string, There is no tension. If there is no tension, it will not move in a circular path. Then I have the weight of the block, which is mg, which is going in the vertical direction. Then I have the normal reaction n, which is going upwards. Now I have to assume that this is moving on a horizontal path. So what I assume is it is going inside from here with a velocity v. It is going inside, and from the other end it will be coming out. It will be coming out with, from the other side it will be coming out, and I will be showing it as a dot. Now I have to resolve the forces in the three directions. What are the three directions? Can anyone tell me what are the three directions? The first direction is the tangential direction, and tangential direction will be inside. Tangential direction will be inside. Now in this tangential direction, will there be any force in the tangential direction? What will be the force in the tangential direction? Anyone? Number one, what will be the force in the tangential direction? It is moving on this horizontal table, and it is moving like this. So there will be friction force which is acting in the tangential direction. If it is moving like this towards it is moving in the inside direction, frictional force will be outwards. If it is moving outwards, frictional force will be inwards. Frictional force is always opposite. So howsoever it is moving on this plane, the frictional force will be opposite to the motion. Yes or no? Do we understand this? Can anyone hear me? Yes or no?
Yes, sir. Clear, sir.
Nashita, you say something wrong with your mic, beta. Yes, I think my voice is clear. Okay, so in the tangential direction, the only force acting would be frictional force. Do we understand this? Yes or no?
Yes, sir.
And what is the value of frictional force? The value of frictional force will be equal to mu multiplied by n. Yes or no?
Yes, sir.
The only thing is we have to find out the value of n. How will you get the value of n? We will come to it. Don't worry. Let us first write the second equation. In which direction we would write the second equation? The second equation will be written in the direction of centripetal direction, towards the center. Can anyone tell me what would be the force in the centripetal direction? Which force is acting towards the center? Oh, anyone can tell me that?
T equals to V square R, sir.
Josana is also telling me your voice is not clear, sir. I don't know what is wrong with my voice. Can you all hear me correctly, clearly?
Close. Yes, sir.
Everyone in the offline class can hear me. What about students in the online class? Why are they not able to hear me? I don't know. I'm sorry. Let me check out my system. Give me a minute.
Sir, it's clear, sir.
Okay. So in the centripetal direction, what is the force? The only force that is acting there, again, I've used the wrong color pen. Let me use it. The only force acting here is the tension force, T. Total force is T. This T must be equal to mv square by L. This becomes my second equation. Sizing is clear. So Jyotsana, you need to check up your mic or your headphone. Centripetal direction. Then remains the last part, the last direction, and I will be very pleased if anyone can tell me what is the force and what is the equation in this direction, the third direction, perpendicular direction. If you can understand this, bacha, you must congratulate yourself. F net must be equal to 0 here. Can anyone tell me what is the equation in the perpendicular direction?
N equals to mg, sir.
Great. N upward, mg
Downward.
downwards. They must equate each other, and n equal to mg. And you must now congratulate yourselves that you have solved the entire question following the principles that we have studied. Make the equation in three directions. The first tangential, think about the tangential direction, the direction in which the circular motion is happening. It keeps on changing always, but you have to only think about the points at which you are making the equation. Tangential direction is only one force, which is frictional force, which is always equal to mg in this case. If n is different, if n is not equal to mg, and we will do those cases where n is not equal to mg. That will be coming up in the next class, don't worry. Tangential direction, there was only one force, frictional force. Centripetal direction, there was only one force, tension force. In the perpendicular direction, forces must equate. These are the three lovely equations that we have made, and that has made our life pretty damn simple. We have changed nothing. We are doing the same thing that we are doing in the chapter known as Newton's laws of motion. There, one direction was this, other direction was this. Here, three directions: tangential, centripetal, and perpendicular. Do we understand this? Can I have some raise hand one last time for this class?
Yes,
So
sir.
that I can move on and wind off this class. Okay, well done, bacha. Yes, I see you from the corner of the screen, bacha. I can see your hands. Well done. This is how you must participate in the class and give answers. That gives me confidence that you are being attentive in the class. What I'm going to do now is give you a small homework, and that small homework consists of what questions are there in the sheet, and I would ask you to do those questions in the sheet. We had discussed problem number 15, as you can see right now coming on your board. Problem number 15 we have discussed. I would like you now to try to solve the remaining problems. If you can do it on your own, well, I will not have to do anything, and you are done with motion in a horizontal circle. Problem number 15 is what we had done. Then we have problem number 16 coming up in the next class. If you can do it on your own, that is very good. There is a ring, something of a ring, and something is moving on a ring. This is something like a death circle. We will discuss what is this death circle.
Sir, we don't have sheets here. We are in the hostel, sir.
Not good, not good. You don't have that soft copy that I sent you, bacha? Don't have that soft copies also? No, no soft copies. Okay, no worries. If you don't have this, we will discuss in the next class. Don't worry. Anyways, I will discuss it. I was just wishing that if you had those notes, you could probably discuss it. No matter, doesn't matter. I will discuss in the next class. I hope you enjoyed this class, and I think the time is already over for your next class. You won't be waiting for your next class. I leave you now. The class is dismissed. Move on to the next class. We will see you on the other side. We'll be discussing some really good problems, and once you understand those problems, life becomes very easy. Again, I'll end up by giving you a small note. Stay safe, stay home, stay in your hostel, get vaccinated. I hope you are getting vaccinated, and I'll see you in the next class. Take care. Have a nice day. Tata. Bye bye.